In this video, we're going to be looking at discontinuous functions and how you can tell whether or not a function of two variables is discontinuous. Now, I'll tell you right now, if you want to follow along, what I'm doing is I'm choosing the g of x comma y function from example 1 of section 12.6. So if you want to pause right now and look at your textbook, that might be helpful. Let me make sure that we've got the plots command loaded. And I think what I'll do is we'll look at the plot 3D first. So let's see what this function looks like. It's x squared over x squared plus y squared. Now you might notice we're seeing something that we haven't seen in our other graphs. We are seeing this gap, and you can see it actually on both sides of the function. What's going on here? Well, let's box this and let's think about what's happening here. The origin, 0, 0, 0, is at the very bottom of the box in the center. So you notice some interesting things happening here. Along this function, if I approach along the positive y direction, I am approaching the origin at height 0. But if maybe I'm approaching from an x direction, here's the positive x direction, and I go towards the origin, I appear to be approaching 1. So notice something. Very close to the origin, I've got some pieces of the function approaching a height of 0, and some pieces of the function approaching a height of 1. That seems very strange, and that should be a clue, along with the fact that you see a hole in the graph, that we have a discontinuous function. In other words, in a very small area, we have very different values. Now let's see what happens when we do this on the contour plot. Contour plot will actually take a little bit of time, and hello, contour plot. There we go. Now you might note it looks a little bit weird here, so you can kind of see that we've got some contours here that kind of move away. This actually isn't a very accurate picture. I can force a more accurate description by using the grid option. And what this tells Maple to do is to sample 100 times in each direction, x and y. That is much better. So note what's happening here. You can note that as we approach the origin, we get some low values, the dark red, and we get some high values, the light yellow. So again, it's the same idea as the picture we saw below. In a very small area around the origin, you are approaching very different values. Whenever you see this type of behavior, what you have is evidence of a discontinuous function of two variables. In other words, everything's not approaching the same value, it's approaching different values.